Welcome back to BAS 121. We're on Chapter 11 and we're talking about risk and simulation. So I've called up our famous outsourcing decision model, and just a reminder, this is one where we can manufacture in-house with the following fixed costs. Our unit variable cost is $125 per unit, and we have a supplier that wants to that'll sell it to us at $175 per unit, and our production volume is 1,500. So it'll cost us to manufacture those in-house, the $50,000 of fixed costs plus the $125 per unit times the number of units. So it'll cost us to do this in-house $237,000. To outsource it, it'll cost us the $175 per unit times the number of units. So, which is 264, and down here we've just subtracted the 2 and then put an if statement in here to say if it's cheaper to do in-house, we'll manufacture it ourselves. If it's basically cheaper to outsource, we'll outsource it. So we have a tremendous model here, and all is well and good, except when somebody says, well, what about the risk around this, or the simulation, or we're guessing at this production volume of 1,500. What if that varies significantly? And we've just started negotiations on unit costs. What if we don't get the $175 that we think we're going to get? What if it's going to cost us $200? What if it's going to cost us? What if we do especially well in negotiations and get the cost to come down to $165, say, for example, or $160? Well, this is where, now notice we've had if we click on our Analytic Solver platform from Frontline, it pulls up a whole menu of different modeling and optimization and solving, all sorts of good stuff. So let's take this from the example out of the book, and let's say our supplier production model, let's say that we want to make that an uncertain model. Now, when you do an uncertainty, it has to be a cell that's a numerical value, because you can't simulate characters. So let's make this a common, and let's make this a triangular. Now notice what's going to pop up. Let's say the best, we might get them to come down to $160 per unit. Remember, we're forecasting unit costs. Our most likely scenario is the 175 that we had in there. But they might be especially tough in negotiations. It might be as high as 200. And we just hit save. Now what we've done, and notice it's already done, it's put this in there, this Poisson triangular. And if I don't like, I've rounded my cell by the number. If you don't like that, you can always put a round function in front of that if you don't like rounded numbers. So notice if I hover over this guy a little bit, it pops up the triangular function that we have. Now the other thing that's uncertain is our production volume. So let's make this a normal distribution. And let's say that it's normally distributed with a mean of 1,000 and a standard deviation of 100. Now, if you're asking me how do we know this, other than it's what the book says, in the real world, you're not going to know exactly what these numbers are, obviously, but at least it gives you some sort of parameters to tell the computer to run the simulations. Now, notice that one gave us, so I can just put a round. That, put a parentheses, and how many digits I want to round to is 0. And there, it rounds it to, for me, to the production volume, because obviously you don't make fractions of a production unit. All right, so now it just becomes a question of, all right, what am I trying to solve? Well, I'm going to try to solve here, and I want the results of my simulation to be output in this cell right here. Okay? So that's how I set that up. Once again, I go to the cell I want my results on. I hit results, and I said put it in cell right there. Now we're about ready to run a simulation, but the first thing we got to do is we got to tell it what options for the simulation we want to choose from. Well, trials per simulation, I think 1,000 trials. You want more than 1,000 trials, you could put 2,000 trials. Okay, run it 2,000 times. Run one simulation. Simulation random seed. Well, let's start at 1. Let's do a Monte Carlo simulation, and let's hit OK. Okay, now we've told it the options. Notice over here on our model specification models, it's keeping track of our uncertain variables that we've told it. Now we're ready to run the simulation. So we're going to say simulate, run once, and it comes up with this distribution here. Now, notice here's all our distributions of our 2,000 runs for all the variable outcomes, potential outcomes, and we see it here on a frequency distribution curve. Now, remember we said if it's a negative number, that means it's cheaper for us to produce and we'll want to manufacture it. If it's more expensive for us to produce, we'll want to outsource it. So if we put in here a lower cutoff of 0, because that's what we're deciding, and now we say simulate, run once, notice now it sort of color codes it for us, and it also gives us these percentages up here. So when we run the simulation 61% of the time or 62% of the time, it makes sense because our costs will be lower for us to manufacture, and only 38% of the time does it make sense to outsource. And we've run this scenario 2,000 times, I think. And there's, you can see it gives us all the statistics. The mean is on average we save $3,000. The standard deviation is 9,000. It gives us all those standard statistics that we normally get. Standard error, confidence intervals, all sorts of stuff that we've learned about. But this is probably what a manager would be interested in knowing. Notice it makes 62% of our simulation times we want to manufacture in-house, 39% outsource. We can look at a cumulative distribution, same thing, reverse cumulative distribution. Now this is important, sensitivity. So the cell B10 seems to be the most sensitive. And what is that variable? That's the unit price. That makes the unit price that we get quoted from the supplier is the biggest factor, right, in this decision making. So, and then we can do scatter plots and it shows us different stuff. So that gives you all sorts of information on the outsourcing, how to run a simulation. Hope that helps. Any questions, let me know.